Mr. Smith, can you help me out with a math problem from the homework? I don't understand it very well, and I want to make sure I understand it for the test.
Sure thing. What is the problem you had in mind?
It's number 10 from the homework. The problem is, a family is off on a hike having left their leftovers out on a picnic table. A colony of fire ants 600 feet due north of the table detect food and begin their march traveling at 4 feet per minute. At the same time, a colony of black ants 800 feet due west detect the food and begin their march traveling 5 feet per minute.
Okay, what is the question asking you?
The first question asks, how long will it take each colony of ants to arrive at the picnic table? The second question asks you to write a function to model the distance between the two colonies of ants in terms of time, t, that has elapsed since each colony began their march. The third question asks, the family returns from their hike to clean up their food when the colonies are 500 feet apart from each other. How long have the ants been marching?
Okay, let's state everything we know about the problem and then write it out before we begin to start the problem. Distance the fire ants are from the picnic table, which is 600 feet. We know that they are due north of the table and that they march at a rate of 4 feet per minute. We know the distance the black ants are from the picnic table, which is 800 feet. We know that they are due west of the table and that they march at a rate of 5 feet per minute.
Okay, is that all we need to write down?
Not yet. We still have to identify the independent variable and the dependent variable. To find the independent and dependent variables, we must first ask ourselves what variable causes the other one to change. In this case, when the time the ants have been marching changes, the distance the ants have traveled changes as well.
So the independent variable would be the time, and the dependent variable would be the distance the ants traveled.
You're right. Now let's draw out our problem to give us a visual aspect of the problem.
Problem restated, and here's a visual aspect of how to write the problem. Here are the questions that the question is asking from us, and then here are some formulas to keep in the back of your mind.
So let's go over the first problem. Time is modeled by the function time equals distance over rate. The red ants march at 4 feet per minute and are 600 feet away from the picnic table, and the black ants march at 5 feet per minute and have to march 800 feet from the picnic table. The functions of their time are respectively t equals 600 feet over 4 feet per minute and t equals 800 feet over 5 feet per minute. Therefore, the time it takes for the red ants to reach the table is 150 minutes, and the time it takes for the black ants to reach the table is 160.
Now let's go over the second problem. First, the distances between the colonies and the table are modeled by the parent function. Distance as a function of time is rate times time. However, the starting point of the ant colonies must be taken into account. So, the red ant colony's distance from the table is modeled by the function distance as a function of time is 600 minus 4 times time, because they start from 600 feet away. And the black ant colony's distance from the table is modeled by the function distance is 800 minus 5 times time, because they start from 800 feet away. Now that we have the lengths of the sides of the triangle formed by the distances between the ant colonies and the table and the distance between colonies, we can use the Pythagorean theorem to find the length of the hypotenuse, or the distance between the colonies. To visualize this, let's look at the graph again. These formulas are now the lengths of the sides of a triangle formed by the paths of the colonies and the distance between them at any given time. So now we can use the Pythagorean theorem to find the distance between the ant colonies. The Pythagorean theorem is modeled by the function a squared plus b squared equals c squared. A and b, we can give the values that we have for the distances between the colonies and the food. And c, we will give the value of the distance between the colonies. So if we put in our values for these terms, we get the function 800 minus 5t quantity squared plus 600 minus 4t quantity squared is equal to c squared. And when we take the square root of both sides, we see that c is equal to the square root of 800 minus 5t quantity squared plus 600 minus 4t quantity squared. So the distance between the colonies at any given time is square root of 800 minus 5t quantity squared plus 600 minus 4t quantity squared.
To the third question of how long have the ants been marching when they are 500 feet apart from each other, we want to plug our formula into the calculator. To plug in the formula, we would want to plug in the function y equals the square root of 800 minus 5x quantity squared plus 600 minus 4x quantity squared. To do this, you press the y equals button on the calculator and then type your formula y equals the square root of 8 minus 5x quantity squared plus 600 minus 4x quantity squared into the y equals 1 line, and then type 500 into the y equals 2 line. Click on the window button and set your x minimum and x maximum values to -10 and 170, and then set your y minimum and y maximum values to -10 and 1200. Finally, click the graph button and your calculator will graph both functions. To our answer, we first need to find the intersection of the two lines. To find the intersection, click the second button, then click Trace button, and click the number 5 to find the intersection. A small X icon will appear. Move that to where the two lines meet, click the Enter button 3 times, and the X value will be your answer.